So, this last talk is by National Instruments, Neel from National Instruments, former ATIS, and now Emerson. Is that correct? Yes. So, I have a feeling that we might have messed up in, where we are putting this presentation in. Because NI is definitely not one of the startups that is coming from OAI. Yeah, we have a long-standing relationship for the longest time. The open source, and as Christian was saying in the beginning, there were radio cards that were developed here, and then USRPs were off the shelf available, and that really enabled things significantly. And now with all the developments that have been happening in recent years, from B series to N series, and now, the X series also, and now more and more moving into more advanced ORAN type implementations as well. One thing I wanted to say about Neel, he's principal engineer at NI and ATIS before that for a number of years. But Neel is very well known in the community. Everybody who is on mailing lists probably has seen Neel respond to questions there. And that reminds me, it'd be great if everybody can sign, whoever is a contributor into OAI, technical contributor, signs up to mailing lists. Because there's a lot of action that happens there. And Neel, thanks for all these years of responding to questions there and being a technical leader and really making people's use of USRPs so easy. Thanks very much.
Thank you, Irfan. Thank you for your kind words, and thank you for your support. My name is Neel Pandeya. I'm here with my colleague Amar Haj Omar from National Instruments. I'm based in Austin, Texas, in the United States, and today we'll talk about some of the reference architectures that enable 5G and 6G with the USRP devices. We just do it here? Okay. So as a quick overview of what I'll talk about, we'll talk about the X410 and X440 radios. And I'll talk about some of the implementations and reference architectures that we provide with our partners. There's an AIML Deep RX neural receiver, an FR1 reference architecture and testbed, an FR2 version of that, and the ORAN ORU based on the X410 radio. Just as a quick background, the USRP products span a wide variety of capabilities and features, and this slide is included as a reference so you can go back and see what the differences are between the different devices. The ones that are highlighted in green are ones where one of the key focus applications is 5G, and so that includes the N300 series, the N310, the N320, and of course the X410 radio. The X410 is a relatively new radio we introduced about 2 years ago. It covers a frequency band between 1 meg and actually 8 gigahertz. It can tune as high as 8 gigahertz. And the bandwidth is 400 megahertz per channel. And it provides 4 transmit channels and 4 receive channels. And this is one of the key devices we use with OAI and other related tools. The X440 is a newer device that we introduced last year. It is a baseband-based device. Both devices use the Xilinx RFSoC chip. This device provides 1.6 gig of bandwidth per channel across 8 channels, but that is at baseband. There's no tuner or RF front end on this device. I'll talk about a couple of test beds and reference architectures. First is the FR1 reference architecture, where we took the OAI software and implemented that as a reference design and a test bed for people to use on the X410 and the N300 radios. And this is in a monolithic split 8 configuration. So we have instructions online and a guide as to how to set all of this up and get the USRP radio working with the OAI software for the core network, for the G Node B, and for the UE. An example of that is here with some of the capabilities that you can use. Some of the channel bandwidths up to 100 megahertz in FR1 are supported. You can use a handset such as a real COTS handset, Google Pixel or an iPhone. You can also use a USRP as the UE, or you can use a modem module, say from Quectel or Sierra Wireless on the UE side. The core network and the radio access network are implemented on separate servers in Docker containers, and the radio the USRP radio serves as your radio front end. We took that and worked with our partners very closely to implement an FR2 capability of this reference architecture. So we worked closely, and a special thanks and shout out to the folks at AlbiSmart, TMY Tech, Eurocom, and we did this also collaborating with Fraunhofer, HHI, in Berlin. Special shout out to Matthias Melhoz, Luis Pereira, and also with RWTH Aachen in Germany. And we put this together to illustrate how you can achieve FR2 capability using the OAI box solution and the USRP X410 radio and the TMY Tech front end, up converters, down converters, and beamformers. And so this presents and provides a FR2-based OAI capability based on the USRP radios. We also have a lot of practical, real-world implementations of these test beds. One is from ARA. We'd like to highlight from the NSF Power Program in the United States. Professor Hongwang Zhang just spoke earlier this morning, along with his PhD student Joshua, have done a lot of good work on his team in Iowa with the ARA platform, which leverages a lot of USRPs for agricultural monitoring applications using OAI and the USRP radios. And it's an example of a practical system solution that really tackles real-world problems. We also work with NVIDIA and leverage GPUs and have created a reference architecture based on the DeepRX neural receiver. And we had a demo of that at the IEEE 6G Summit in Dresden, showing the RX receiver optimizing for channel impairments, which were implemented on the vector signal transceiver, which is shown in the green box below. It's not a USRP device, rather it's a VST, a vector signal transceiver device from NI, where the channel modeling occurs and introduces various impairments, and the DeepRX model is able to overcome those impairments and maintain the integrity of the channel and the link. We have a demo of that and a reference architecture based around that. Some other things that we provide are this data recording API, which is a way of automating large recordings and data sets. And so instead of having to do that manually across multiple devices, multiple channels, and configuring things manually, you can define everything in one YAML file and run that YAML file against an agent, which will then perform the desired data recording. And so if you're trying to capture large data sets for AI/ML applications, you can do that using this recording API and automate a lot of that data capture operation. It saves all the data in the SIGMF format, so it's an open, standard open format that includes metadata to annotate the data capture and creates a hierarchy of all the data, so you can go through hundreds or even thousands of data files very easily and automate the creation of those data files. I'll talk next about the ORU. We're currently working very actively on implementing an OpenRU with the USRP X410 radio. And so we've taken the split 8 monolithic configuration and taken the 7.2 split and put the low physical layer functions, the low PHY functions on the FPGA of the X410 and have added a eCPRI interface for the DU. And so we have this running at a IEEE 6G Summit conference in Dresden a few months ago as a preliminary beta demo. Here in this workshop, we have a video demo of this system running, which shows a downlink spectrum and constellation. And you can see that tomorrow afternoon in the demo session. And in this implementation, we take the standard X410 hardware. There's no difference or no change or no modification required. We flash a different FPGA image onto the device, load software onto the ARM CPU of the device, and it acts and behaves as a standalone ORU. You don't need to connect it to an external host computer or anything like that. It comes up by itself and provides an eCPRI link to the DU and performs all the lo-fi functions. This beta version of the emulator provides some capability as shown on the slide, where we have 1 gig and 10 gig interfaces, various FFT sizes and numerologies, C-plane and U-plane support. S-plane support is coming later. M-plane support is also tentative. And we have 4x4 support planned for next year as well, along with a few other features. This beta release should be ready for general use or early access by the end of the year, so in the November timeframe. Special thanks again to all of our partners and collaborators, and especially the folks here at EuroCom for hosting us. Thank you very much. We'll be having a demo tomorrow, and we are also working with All Be Smart, and they have a demo as well. So please come and see us in the demo session. Thank you very much.
Thank you very much, Neel. Any questions for Neel?
Thank you for the presentation, Neel. Very insightful. One question I do have is about the FR2 support that you're mentioning. So right now, this is let's say a solution that you provided with Admitech for the IQ mixer and the front end with the LNAs and so on and so forth. Are you planning a more integrated solution down the road? I mean, up to at least integrating the IQ mixer inside the X410 or a new version of the X410?
Yeah, there are some plans and some things we have on the roadmap, but it's very preliminary right now. So we're not announcing anything at the moment, but yes, there are some things in the work. We'll have more information early next year about that. Right now,
okay. So for the moment, there is no date, no release date announced for that, right?
No, not at the moment.
Okay.
Yeah.
Thanks a lot.
Thank you.
Thanks, Neel, for the presentation. I just want to know more about this RU white box that you were saying. I know it's very like a timely topic and timely needs in the community. And you explained that for the moment you're only working on a C-plane and the U-plane. But does it mean what level of openness this white box is providing to the community?
Yeah, thank you. I should have mentioned this. The implementation that we have is completely open. So all of the blocks on the FPGA and all of the software running on the ARM CPU is open and open source. So it's meant to be a platform that's completely open for people to serve as a platform for innovation and modification. So it's an open platform. Yep. All the software, all the Verilog code, everything is open source. Yes, please.
Thank you for the presentation. I just have one question about the ORU that you're introducing. I noticed that the interface that you put between ODU and ORU was in eCPRI. So it means that you're opting out implementing the 7.2 interface, or is it going to be the standard ORAN 7.2 interface at some point between the ODU and your implementation on the USRP?
It's an ORAN 7.2 implementation over the eCPRI.
It uses the same library. So any DU that implements the 7.2 library should be able to connect with your setup.
Yeah, that's our goal. That's right. We haven't started any interoperability testing because the device is in beta right now, beta development, beta testing. But yes, that is the goal, to interoperate with different DUs.
So now that I imagine you're working with OAI on that front as well, yes? For
yes.
DU. So you're using the same 7.2 library of OAI for your testing, or is it that you're developing a different one?
No, we're using and working with OAI.
Okay, excellent. Thanks.
Yes, thank you. Okay, thank you very much.
Thank you, Neel.